So here what we're told is that p is the product of the first consecutive integers. So it could be 1, 2, 3, 4, 5. We don't know how far it goes, up to n, let's say. And what we're told that when we write out p in a multiplied out form, then the last 6 digits are zeros. So we're given that. Question is, what's the least possible value? So the way you want to think about it is, how far do I need to multiply that we end up with 6 zeros? You can go further, but you want to go as little as possible as far. So the key thing is, how do we end up with a 0 when we multiply a number? Well, a 0 corresponds to a 10, and a 10 is formed when you have a single 2 and a 5. So if you think about the prime factorization here, it's really about counting how many pairs of 2s and 5s we have. If we end up forming 6 of them, so for example, if we just look at the first 5, you will see that we have a single 5 and a single 2, so we'll get a single 0, and you can check this. This will be 120. And that 10 is being formed by this pair of 2 and 5. Now, there will be a lot of 2s. You have every other number is even, but you'll have a far less number of 5s. So it's really about counting 5s. So the first 5 is going to appear at 5. The next one will be at 10. So let me just write how many are going to appear here, 10. So up to 10 factorial, you'll get 2 zeros. And then 15, you're going to get one more 0. 20, you're going to get one more. But then at 25, because it's 5 times 5, you'll get 2 5s. So if we look at 25 factorial, its prime factorization, you will have 5 to the power of 6, and there will be a lot more 2s. We actually don't even need to count those. And so we will end up with 6 zeros here. Now, that's the least value for n, and that's what the question is asking. If you wrote 27 factorial, well, that will also have 6 zeros. But notice the question is, what's the least possible value? So that's why the answer is 25, not 26, not 27. All 26, 27, 28 factorial, all these will have 6 zeros, 29 factorial. But then once you get to 30 factorial, you'll get another 5, and 30 factorial will have 7 zeros. So I've seen this kind of a variation of this question on GMAT. And the key thing is to kind of recognize how these zeros are forming and how that is linked to the prime factorization of this n factorial. So that's the key concept. The answer is 25, choice B.